Welcome to the webinar on the key skills that you need to succeed as a data scientist. Thank you so much for joining us. We really do appreciate you giving up your valuable time for this. We've got a wonderful panel of speakers who I will introduce shortly. But before that, I just wanted to say a few words about the Career Accelerator. First of all, I should have said my name is David Avery. I work for Fourth Rev, and I manage the relationship with the University of Cambridge. So the program, so data science with machine learning and AI Career Accelerator with the University of Cambridge Institute of Continuing Education in partnership with Fourth Rev. It's a comprehensive 7-month fully online program, and it's designed to equip you with advanced data science skills, which you'll gain with hands-on project experience and industry insights, all of which are designed to let you excel in today's competitive landscape of data science. So it's led by experts from the University of Cambridge in collaboration with industry leaders. And that indeed is one of the massive advantages of the program. It's not just academic, it's not just industry-led, it really is the best of both worlds, so to speak. And it covers cutting-edge topics like natural language processing, like time series analysis, Gen AI, large language models, as well as the sort of the foundational statistics required to understand what's going on under the hood of these models. There's a fully very detailed course on supervised learning in there as well. But the point is that all of the technical material is applied to business context, and it's extremely hands-on. So within the program, there's 20 plus sort of industry relevant projects that can be added to portfolios. And some of those, the assessed projects, use data and business challenges set by real companies as well. So that includes companies like Pure Gym, like Study Group, like Nielsen. But the sort of one of the standout features of the program and the way that it culminates is a 6-week live employer project with the Bank of England. So in that you'll get into teams and you'll simulate the actual environment of working on a live data science project. That is a genuine business problem that the Bank of England are having. It's to do with the way they are monitoring banks, looking at their financial earnings calls, which is part of their remit. And they want to see if using data science techniques, such as NLP and other techniques, they can spot different trends on earning calls that perhaps may otherwise be hidden by sort of just looking at financial reports. So it's a really exciting project to culminate. And then just to sort of sum it up, with personalized career coaching as well, flexible payment options, and as I mentioned, that curriculum that aligns to real business needs. It's a program that really should be quite transformative. So just a few more housekeeping bits and pieces. Shortly, I'm going to introduce our panelists. They are going to speak about a range of topics, and then there will be time for questions at the end. The session's going to be an hour long and recorded. To ask those questions, could you please use the Q&A function, which is at the bottom of your screen in Zoom? Those are the questions that we'll be going through. So without further ado, panelists, could I please ask you to turn on your cameras now, please? And then I'll ask you to introduce yourselves one by one. And we'll just do this in the order that you're appearing on the screen for me. So for me, that's Alex first. Could you please say a few words?
Hi, everyone. I'm Alex Smirnov. I'm a data science consultant. I've been doing analytics for about 10 years. Before data science was cool, across a range of markets. And at the moment, I'm consulting banks on how to use data science to improve their marketing and product features.
Very much. Devaka.
Hello, everyone. I'm Divakar. I've been analytics and data science practitioner for over 15 years, predominantly in financial services, e-commerce, and logistics. Currently, I head up a data science and analytics team at a e-commerce tech startup called Doji. I'm involved in the program as an industry mentor. Thank you.
Thank you very much. Robert.
Hello, I'm Robert Hardman. 25, 30 years now experience in data analytics and its application to industry, ranging from finance through to telcos, through to airlines, and now bringing it into that area, how we can accelerate that with the use of artificial intelligence on top of these techniques.
Thank you, Robert. And finally, Giovanna.
Hi, everyone. I'm Giovanna. I'm a researcher in artificial intelligence and deep learning. I did my MPhil and PhD at the University of Cambridge, and I am the tutor for course 2 of the Data Science Accelerator. So happy to be here.
Thank you so much. Right, well, I'm just going to start off with a really, really broad question, which is, what do you believe are the most critical skills that define a successful data scientist today? Yeah, would anyone like to start us off on that one?
Well, I'll give it a go.
I was going to say,
you know, critical thinking is one of the, we're problem solvers, and and we have a tool set, and that tool set can be defined as a set of mathematical algorithms. It could be just being good at a spreadsheet. The ability to extract and summarize a problem, understand what that problem is, take it away from all the business noise that's around it, look at it, and then realize where you've seen these problems probably somewhere before, so that you don't just go A, B, C, D, E. Most problems in any industry are very, very similar. If you can abstract it out to a sort of a mathematical approach, and then look at your tool set, be critical, and then bring it to bear. And I think a key skill is having confidence in what you do, and that when you present an answer that you can argue for it.
I would just like to add a couple of quick points, Robert. Completely agree. Problem solving is up there, right? To be a successful data scientist. Couple of things which I think will become probably more important going forward, along with problem solving, is business acumen, right? Because I think unlike data engineers and ML engineers, data scientists are working with the business or expected to work with the business, right? So with their problem solving skills, if they have a domain knowledge or domain knowledge, industry knowledge, business acumen, that will take them a long distance in defining the problem, defining the data science problems. The second one, which is probably increasingly becoming important now in the data science world because it's very broad, is the breadth of knowledge. It's not just the depth of knowledge, right? You have the right problem solving skills, you have the business acumen, but when you work with a business in a different problem, your breadth of technical knowledge in data science can help you quickly define the problem, define a solution, right? Or set the direction for the team. I think those are the two I feel could be key aspects of becoming a good data scientist.
I just like to agree with both those things. Very much so. Subject matter expertise will save a lot of time and misunderstanding before you jump into it. A good rule of thumb is 7/8 of the time I like my staff to spend thinking about what they're about to do, and 1/8 of the time actually doing it. Activity doesn't equal productivity, and I find the pressure on people to be active as opposed to be thinking about what they're doing quite a problem.
Really good point. Really good point. So similar question, but sort of framing it slightly differently. How would you say these skills have evolved in recent years, particularly with the emergence of AI and other technologies? how's the role of data scientists changing?
I can start with that one, and then I think probably others can jump in. So what I have felt personally, like, 5 to 8 years ago, right, when I wouldn't say that was the initial stage of data science, but I think more it became more mainstream, right? Every organization you speak to were predominantly working on the proof of concept, POCs, right, or the greenfield projects, and the focus was more on, okay, let's build a model, get some results out of it. Let's see, what is the art of possible. So that was the stage like 5 to 8 years ago. And how I have seen it evolve is now people are talking about deploying it, right? Getting the benefit out of it, monitoring the models, right? So you're not at the same stage of just doing the POCs, but more towards getting the ROI returns out of the data science, right? And during that journey, what has happened as a data science practitioner has to focus not just on the breadth of knowledge in data science or technical, but also other skills, or not just the model development aspect, but also the model deployment, ML ops, right? So a lot of data scientists, upskilling themselves in ML ops, or ML engineering side of things. And the second area I have seen, because of the cloud has been massively adopted as well in the last 8 to 10 years. So data scientists had to really keep up with the cloud native technologies, right? Docker, or Azure Databricks, or whatever number of technologies, Amazon SageMaker. So I think these two were the other skills the data scientists had to really adopt in last 5 to 8 years.
I'll back that up again, that no data scientist is an island unto himself or herself. You're embedded into a whole system, and you cannot sit there and say, someone's going to pass me data, and then I'm going to do this and pass it on. Everything is connected, and you, as a data scientist, need to understand from beginning to end, where it's coming from, right to the point where, what are the board of directors going to do with this information that I put in front of them, and everything in between. So you cannot isolate yourself from the environment, the ecosystem that data science sits in. Once upon a time, all they did were write reports, and data science was defined by the tools rather than the problems. So there was spreadsheets, and then there was BI this or BI that. And it was the tools defining what a data scientist was, which was always not a good thing. Now data science is, shall we say, moving away from being users of tools to being what they should be, for those that were always good, problem solvers, the ability to see a business problem, look at the data and see an analytic solution, an evidence-based way of solving that business problem, and then connecting the bits of how they're going to do it. They might use AI, they might use pen and paper. It still works. So do not limit it by, these are the tools and therefore that defines my role. No.
One thing I'd probably add on the banking side is what I see is, number one, clients demand a lot more ability to interact with the data and double click, so to speak. And that includes all the way up to CEO level that Robert mentioned. So there's obviously a lot of work to be done, including on ML ops to make that happen, to make sure the tools are fast enough. And also the second and somewhat related point, on the Gen AI, I know that a lot of my clients are currently building the ability to almost talk to data, right? So to kind of remove the data scientist as a middleman, so to speak, and then allow users to talk to computers to get those detailed insights for which you needed business analysts first. But then, of course, what it means is that people like us then need to make sure and enable this technology. And actually, I think that's for the best, because that would allow us to work on interesting problems, as Robert says, rather than actually running around helping with some minor PowerPoint slides for ad hoc queries.
Thank you, everyone, for that. So, yeah, we, starting to get an understanding. It's all about, driving value to the business, about critical thinking, about all those things. Nonetheless, you do have to have technical proficiency to be a data scientist, and that's what my my next question is going to be all about. So, what would you? I mean, Giovanna, maybe I could come to you for this one. From your point of view, what are the sort of the foundational technical skills you would need to be a data scientist?
Yeah, so nowadays, let's say that with the arrival of the massive AI use, there is this idea that probably, technical skills can be built on the go. But nowadays is where it's more important actually to have solid foundations on certain technical skills and also on mathematical, let's say, and computational background that stands behind these techniques. Because you can be only a user, but if you have at least an idea of what's behind the algorithm that you're using, you can become more and more, independent in the use of it. So talking about technical skills or programming, let's say, definitely a knowledge of Python is something which you need to have among the programming languages. Python together, for instance, with R programming, let's say. It's also true that if you gain knowledge in one programming language and you start programming, for instance, in Python, then once you have gained this way of thinking, it's quite easy to transfer this knowledge to other programming languages, even if it was your first time programming. So you started with a course in Python and you've never seen programming before. This doesn't mean that after you have learned that, you cannot transfer these skills to others, for instance, R or other type of programming language which your company might ask you to use. It's quite easy to then be flexible and transfer this knowledge to other kind of programming languages in this sense.
Thank you, Giovanna. And I might just stay with you for this next one, although everyone else, please feel free to jump in, because I know it's your area of expertise, Giovanna. If you could say a little bit more about machine learning in relation to data science, which is obviously fundamental. And I know if you could say a little answer, perhaps, and mention a little bit about the course that you teach in the program as well.
Sure. Yeah. So let's say that machine learning, let's say, finds in the data a way of, a reason for living, because, of course, machine learning algorithms learns from the data which we give as input to them. So this means that the reason why, let's say, data science was born as a son or a daughter, let's say, of the machine learning techniques which were developed. Now, among the machine learning family, we can find several different types of subfamilies of techniques which you will encounter during the Data Science Accelerator course. And among those in course 2, which is the one I'm tutoring, we will see together the so-called supervised learning techniques. So those techniques in which your, let's say, data science question aims to predict something in particular. So if you have a research question, for instance, like, can I predict the amount of money that my customer will spend on this particular product or something like this? These are, just to give you a very kind of naive example, but these are type of research questions which in machine learning you need to answer using supervised approaches. And more specifically in the course, for instance, we will see very, let's say, widespread and famous methods such as regression, linear regression, logistic regression, and we will deep dive into neural networks. So we will start from the foundations of neural networks and see various aspects on how to optimize algorithms and neural networks implementation. Neural networks that, of course, are the foundations for the latest advancement of AI, so the so-called deep learning methods. So, and also all of the generative AI models, which you see, let's say, around and developed nowadays, are based on deep learning methods, that is, on neural networks-based approaches.
Thanks so much for that, Giovanna. Right, so I know on the panel we've obviously got some very senior data leaders here, and my next question is about common skills gaps. So thinking about, I guess I'm thinking of Robert, Devaka, and Alex in particular, when you're thinking about the teams you work with, the people you hire, what would you say are the most common skills gaps that you see? And also, I guess there's two different ways. There's people transitioning from other careers, and then there are also more junior data scientists looking to advance their careers. Yeah, I'd love to hear your thoughts in relation to those points.
Yep, I can take a stab at it, and then obviously people can chime in. So what I've seen, especially for people who are starting as in data science, right? Whether they are starting in a junior data science or changing in a career, right? From moving from software engineering to data science. I think people realize the technical aspect, like Python or other programming languages, they pick up that quickly. They learn about supervised, unsupervised learning as well. I think that's the first 1 year, right? I think when they start operating as a data scientist in the second year onwards, the key challenge becomes the real life use cases, right? So because the real life examples are very different than what you learn in the theory, right? So that's key, and that's comes on a job or more use cases you work on. Like, David, you mentioned about the real life use case at Bank of England. Another use cases that we do cover as part of industry mentors, running the students through those examples. So I think that's very key, understanding the variety of problems, right? What are the challenges? Because real world data is not that good. Real world, requirements are not that straightforward, right? I think that's the biggest challenge for data scientists coming from different areas. Assuming it's going to be straightforward, like an engineering principle. It is not that engineering principle. And the second aspect I do find for a lot of these data scientists, I think I alluded to that earlier as well, is breadth. And Giovanna explained it quite a lot, that how we try to cover the breadth, because one problem you may be working on computer vision, and suddenly the second one you're just developing a linear regression, right? So that can be vastly different, right? So having a good coverage of the breadth is key. I think the programming, whereas the programming language and data wrangling and other skills, there you probably need the depth, right? And because whether you work on computer vision or you work on simple linear regression, the programming language, this data wrangling skills and visualization skills are the building blocks of your skills, right? Whereas breadth helps you think and solve the problem, as Robert mentioned, right? So because solving the problem is very important. So I think for me, those two are very critical.
Thank you, Devaka. Robert, can I just check if you have anything to add on that? I know you've got a lot of thoughts on this subject.
Yeah, the gaps. And like you said, you've got two types. You've got those coming out of university or their first, second year jobs. And those gaps will hopefully get filled in with experience, because that's where, their first jobs, they treat them as assignments, and at university, they get data that's actually readable and usable. 7/8 of cost, time, and pain, and this is from 15 years of experience, comes down to getting the data. You'll spend more time in doing that. And it is important that you know your data, you understand it before you even get near to putting pencil and paper and doing anything with it. Because you see those common mistakes, which is, here's the data, I'll throw it at the machine and a number of answers will come out. It's like, no, if you don't spend 7/8 of your time looking at the data, seeing what's missing, seeing, is it make sense? Is it what it should be? Is it, as simple things like, oh, it should be weekly, but it's missing data, or, there's been a change here. You have to embed yourself in the data, completely before you even think about solving your problem. And then once you understand that, you then craft, what is the questions I can answer with this data, or what are the approaches I'm going to use? But don't, without fail, I see them throwing data and hopefully it comes up with an answer that makes sense, more in hope than actual anything else. So that critical thing of really understanding the data, what's good, what's bad, what's missing, its subject matter, what it actually means for the business. You know, I'm counting the number of people sitting on an aeroplane. Oh, that's good. When you should be counting the profit that that seat makes rather than the number of seats. That's a huge difference. And these are real questions, you know. Oh, they filled up the plane. That's good. No, they discounted all the seats. We lost money. I mean, these are the sorts of intelligence you must bring to the data before you, formulate the problem you're going to solve. The next part is there's no point in being right unless you can convince people you're right. And that's the Cassandra thing I say. Well, you know, she had the ability to predict the future, but no one would ever believe her, and it didn't end up well for her. You need to be able to put and establish a narrative and, you know, argue your point of what you've done and why this is the answer. If you don't have that part, you have done nothing. And that's the hard part, because therefore you have to embed yourself in the world of politics, because business is in the world of politics. And you're never asked a question unless there's a reason behind it. And it really helps us to get more mature to understand, why was that question asked? Was it really just to get the number, or is there something else behind it, which will help you craft your narrative to make your answer understandable or fit that purpose. So solving the problem is only a little bit of what a data scientist does. Data scientist is now this new role where they have to interpret information that, you know, one end of the business has to take on trust. You know, they will not understand if I say I've done a Fourier transform and I've done this and I've done that and I filtered the data and I removed that. They will look at you just strangely. So you are the interpreter. It gives great power, and with great power comes great responsibility. And that comes with experience, learning from the others around you, learning to be, I would say, you need to be a virtuoso in your tools. But that doesn't make you a musician. That comes with the experience. So, you know, I expect the people to learn those basic disciplines and how to use the tools, but with experience, you know, you turn hopefully into a musician, if I use that analogy.
That was, wonderfully eloquent way of putting it. Thank you. Really enjoyed that. Both you and Devaka, thank you for that. So my follow-on question to this is, because we've now got a really good sense of, from a hiring point of view, what you're looking for, what learners need to develop in to progress in their careers. Has anyone on the panel got any advice for sort of the best way that learners on this call or elsewhere might assess their skills currently and sort of take a critical look at their skills and where they need to develop?
Well, I think I would say that if we start from the end, right, it is important to understand where you're trying to get to, right? Because it'll give you a huge advantage if you know the practices and the tech stack that your favorite organization is using, right? So if your dream job uses Amazon, then learn Amazon, don't use Google Cloud, right? So the easiest way is to find a buddy who can tell you exactly what tech stack they have. And then also as a second point, either ask them for examples of the problems they had and try to solve a dummy version of it, or if not, if that's not available, then try to find that on Kaggle and then see where you fail. I think one word of caution there is with Kaggle, it's easy to get down the rabbit hole and solve problems that might not necessarily apply to business, especially business you are looking to get into. So that's why I think the engaging with practitioners is probably your absolutely best bet. And then once you have the foundation, ChatGPT is your friend.
Great points. Thank you, Alex. Okay, I'm conscious of time, so I'm going to move us on a little bit. For those of you with, good knowledge of the program, Giovanna and Devaka, I think probably have the most detailed knowledge. Based on those skills gaps that we've been hearing about, how would you say that this Career Accelerator helps students to address those gaps? What do they gain from it?
Yeah, I can give it a go, Devaka. So I think the Career Accelerator is actually perfect for both those of you who already have experience in the field, but also for those of you who instead want to give it a start to the data science world, because it will give you a very, let's say, complete overview of the various methodologies that I was talking about before. So starting from defining what is machine learning to then go deeper into supervised and unsupervised learning. And we will, let's say, introduce these topics to you with readings, with live sessions in which you will have the time, the possibility, let's say, and time to discuss with experts and tutors, for instance, what I do with the course too, but also with the other learners. So it will be a very nice way of interacting with a group of people who are interested in working or who would like to work in the field. So you will have very nice possibility of exchanging ideas and learning from the others all together. And together with the theoretical foundations, which we will explain and see together, you will also be very much hands-on, as David was saying at the very beginning. So in each of the courses, in each of the modules, let's say, of the Data Science Accelerator, you will get the opportunity of seeing, let's say, notebooks and Python implementations of what we are seeing in theory. So trying hands-on these techniques and seeing how you actually find yourself coding and programming after you have been reading about these topics.
Yeah, thanks, Joanna. Just quickly, would add a couple of things. So apart from the breadth which Joanna mentioned about covering in this program, the two other things I particularly noticed, Mark, could be very helpful for the students. One is obviously involvement of industry mentors who are bringing to life some of the real life examples in a conversational way, right? You can ask as many questions as you want, understand deeply into these use cases. And second aspect, which is you have an opportunity, or the people have the opportunity to set up one-to-one session with these industry mentors as well, right? We have had few examples before where people have asked, very specific questions about their career advancement, right? Or their challenges, right? So those are the two additional elements that could be very helpful for some people.
Thank you very much, both of you. Want to make sure we have plenty of time for the Q&A, but before we move on, can I ask a sort of a broad question about the future? And obviously this is open to everyone on the panel. Would love to hear your thoughts. What advice would you give to those looking to future-proof their careers in data science, as much as that is possible to do in anything? Love to hear your thoughts. Thank you.
Well, I'll give it a go, because I'm at the end of my career, so I've future-proofed it up to 30 years of going. And I think it's a combination of soft skills, which come with experience. We're social creatures, and we need to be able to interact and communicate what we're doing. And that ability to spin a narrative, I think, is really critical. The ability to be a self-starter, to go out there and learn new things, because things are changing. If nothing else is true, is the skills you have today could be made redundant tomorrow. What isn't made redundant are those fundamentals, having a good understanding of the basics in mathematics and logic. Those things are always there. They might change their name every 3 years, but you're still doing algebra, calculus, statistics. A grounding in those things where you are comfortable will always protect you from the latest software fad, because no matter how they rename it, they are based on those fundamental principles. So the more confident you are at that level, it doesn't mean you need to become a mathematician or a signal processing expert, but to understand those fundamentals to a good working level. And then as things develop, that gives you an advantage where you aren't beholding to a piece of software. You actually understand what it is doing or not doing. And I suppose looking out, and as I said, always learning, that breadth. If I look at my career, most of the techniques I've used in that aren't mine. I've looked at, we have big data problems. So I looked at what they were doing at CERN, where they have lots of big data. How were they solving that problem? Or I looked at what they were doing with, astronomical data, huge volumes. You can take these different learnings from different areas and apply them to what you're doing. So always look out to see what's already being done, even if it's in an esoteric field that you didn't even know was related. People are solving very similar problems, and that gives you a very good grounding to relate changes and what's going on. So in a nutshell, always learn.
Absolutely. I can't agree more with that aspect. And if I were to add one more thing, which I could not, which was key, I was just trying to articulate that, but fit into the other questions as well, is knowing like what is your differentiator, right? Apart from the subject matter expertise and, the industry domain understanding, which is very, very critical, right? Is what is your differentiator when it comes to being a data scientist, right? And there are two specific personas of data scientists. One is very generalist, right? Which is like knows all the breadth of algorithms and machine learning, and the specialist, right? And I think it's 70-30 or 80-20 in terms of generalist versus specialist in data science, right? So you should understand what are those specialist skills. Do you really need to compete in that area? And if you do, right, what is the opportunity in that area? So just to, if you want to, I mean, I've seen some people future-proofing their careers. They have specialized in NLP because they knew that they want to really go deeper into NLP or the computer vision problems, or now the LLMs, right, Gen AI, and there are tons of people who are getting into that. So just knowing where is an opportunity, and knowing also how, how you can create a differentiator for yourself and be relevant, right, along with what Robert mentioned. Yeah. Thank you.
Thanks so much for that, Alex. Giovanna, anything you want to add to this topic?
It's a $1 million question, isn't it? I think, yeah, probably hard to add for me anything over above what Robert and Diwakar said, right?
Yeah.
Get your math solid and get your communication good, and I think that will serve you 99% of the time.
Nicely summarized, thank you. And I can see Giovanna nodding as well.
Yeah, exactly. Nothing more. I mean, he was definitely all of my thoughts were already said by you all. Yeah, don't be scared of your skills aging, because if you get solid foundations, as you were saying before, and also if you learn this way of thinking of a data scientist, so you know that you have to start from the data, you know what to do with the data first, you have to look at the data, you have to understand if there are criticalities, if there is something missing, and so on. These are all skills which will never age, even if the sons and daughters of ChatGPT will come and let's say be much better than what it is now, because these are all skills which will always be needed. So once you have gained experience with them, these are absolutely, yeah, always standing and important.
I'll say one other thing, and it's in the title, data science. There's a thing called the scientific method. And that is utterly fundamental. You question what you do. I see so many people going in to find the answer rather than, uncover the answer. If you go in to find the answer, but you already believe that's the answer you're looking for, which is 9/10 of business problems, they want you to go and prove what they already think is there, you will just become one of many. But when you go in there and you upset it by truly, I call it data archaeology, you uncover truths that they never knew, then you're a success. And it's a very different mindset.
Thank you. Thank you, Robert. Thank you, everyone. Right. Well, that was the last of the questions that I had, but I can see that lots of the audience have been asking questions. So I'm going to turn to those now. We've got a couple of related questions to start with. A question about basically how does the Career Accelerator differ from an MSc? And then someone else asking how it differs from university courses, universities that have collaborated with Coursera and other online offerings, for example. So I might just start with a bit of an answer, but yeah, please feel free to come in. I guess particularly Giovanna, I know you'll have expertise in how this differs from an MSc, for example, which I know you're very used to teaching as well. I would say the fundamental difference. I mean, if you look at sort of online education in this space, you've got the MSCs and the more academic programs, and then there's boot camps. And a career accelerator is designed to combine the best of both. So it is more applied to industry and real business problems than most MSCs will be able to do, because they'll be more focused academically. I think that's probably the fundamental difference to get across, and the key one. And then obviously there is a huge variety of courses out there, all taught in different ways, lasting different amounts of time, different depths, and you'll obviously have to decide which one is right for you. What I would say about this program is it's very intensive. It's 20 hours a week. It is most certainly not a Coursera course or anything at that end of the spectrum. It really is quite intensive, but it has also been designed for working professionals. So there's a strong support team. A lot of the content is asynchronous. There's synchronous elements as well, which you do need to attend. Ideally, you'd attend the live sessions that are once or twice a week, depending on which week it is. But yeah, it is an industry-focused program with the academic expertise of Cambridge that has been designed for working professionals. I think that's probably my best summary of it. But yeah, I guess Giovanna and Devaka in particular, with you both teaching on the program, is there anything you'd add to that?
Actually, not too much on top of what you've said, David. I think, yeah, it combines all of these different aspects. So being very industry oriented, but also academic, let's say, oriented as well, with this interaction between people coming from academia as myself, or coming from companies as the Becca and so on. So it's, yeah, more or less it's the combination of these factors that make it quite new and interesting for whoever is interested in pursuing a data science path.
So next question is, Giovanna mentioned R as a useful programming language, but can I please clarify that it's not taught in the program? No, it's not. Python is the language used in this program. And we do expect learners to have some sort of fundamental skills in Python before joining. Don't worry if you don't, because we do have some courses that will allow learners to upskill in Python before they start. So certainly don't let that put you off applying. But in terms of the Career Accelerator itself, it's Python, and it's about teaching you data science techniques using Python, as opposed to actually sort of learning how to program. Is that about right, Giovanna, would you say?
Yeah, absolutely. Yeah, it's all Python. So Python and R are not so far away. So as I was mentioning before, the transition, so if you start from Python and you learn Python very much, and then you work in a company in which R is more required than Python, the transition is very easy. So because the two programming languages are very common, and also I mean, if you learn a programming language in any case, you start thinking as a programmer. So transitioning to different programming languages becomes much more easier than what it was, the learning investment at the beginning when you first started learning a programming language. So yeah.
Thank you, Giovanna. So the next question, and I'll just direct this to anyone on the panel who'd like to answer it. What would be the difference between machine learning engineers, data scientists, and data engineers? And how could data scientists interact with business lines and others mentioned earlier?
I have some stories to tell there.
Thank you, Alex.
So, typically, when you see a vacancy, right, the job description is written by a recruiter, and they've no clue what they're talking about. So, my last successful interview, for example, ended up being completely 180 from what the job description was. So, but loosely speaking, based on my experience in banking, you probably will have to be each of those in some proportion. So let's say you're a data scientist, right? You're extracting business insights, right? To then pass on to make a new campaign or whatever. The data is not loading properly, it's loading slowly. You have to become data engineer just to get it to work. In an ideal situation, you have a dedicated team of data engineers who make sure that it's all there and you just used ready tables. In my experience, even in some very advanced and famous organizations, that's not the case. You have to know what's going under the hood in Hadoop, for example. Similar for machine learning engineer, right? If you just do one snapshot of analysis, pass it to client every month, you're okay. But if that's something that's based on live data, right, or something that has to work with lots of users, and I'm sure other panels will have a lot to add about that, then you have to become a machine learning engineer to some extent. Yeah, so I hope that covers at least first part of the question. I'm sure others have a lot to say, so I'll pass on to them.
I'll agree with Alex 100%. First of all, HR writes the job descriptions and it's not their fault. They write what they know, and there are now new things, and they have to put them into old boxes and old labels. Those labels were more suited for the mid part of the 20th century, at best. So yeah, the job descriptions are just something they have to do. It's a box ticking exercise. Those roles and the roles that you see in real industry don't even exist they don't. So in one industry, you might be called this and the other. What Alex said is completely right. You need, as I mentioned before, you need to know from the very beginning of where your data is coming from and how to get it. You can't trust the data engineers to get it to you, all the way to the other end of who's this going to be presented to. And if it's a product, you then have to have a good understanding, oh, this is going to have 4,000, simultaneous customers attacking it. And so I need to speak to the application people or the back-end engineers. So you need a working knowledge of a whole ecosystem. And you are the person who's the only one who has a full view of that ecosystem, what it's set up for and what it's to do. So it's a set of skills that no other role has to have. And that can be quite scary. But like I said, no data scientist is an island unto themselves. And you are part of an ecosystem. Think of it as a biological system. You need to understand all the bits to be a successful data scientist. Otherwise, you just become a cog that will be replaced.
Thank you. Thank you very much for that. Next question is, would the industry experts on the panel advise someone from a core marketing and digital acquisition background of 10 years plus to pivot towards data science? Would you consider marketing a complementary experience? I'm going to open this up to anyone that wants to answer it, but just to say, I would say absolutely. If it is, the career that you want to follow and you have a passion for it, then absolutely. But I think the things probably to think about, and I'd encourage you to, speak to an enrollment advisor about this, but it would be thinking about the parts of your role that you've done that are more related to data science. You may have used many of these techniques already, but just not as a data scientist. Think about your Python abilities, whether you have them, whether you need to upskill. Indeed, whether you want to as well. I think that would be my advice. Fundamentally, speak to an enrollment advisor, because they will be able to guide you on the specifics of your expertise and experience against the requirements for the program.
Yeah, David, I can add a couple of
thank you.
Marketing as well. I was directly working with head of marketing in my last project, last organization, right? So will marketing be complementary skill and whether it's relevant, right? I think one of the first use cases we had in data science, I think as an industry, marketing was very prominent. Marketing optimization, if you've heard like marketing optimization, propensity modeling for below the line marketing were very, very, relevant use cases before we started having, fraud and risk side of analytics and data science as well, right? So marketing plays a huge role. It's a very broad area. It is going through automation. That's what my external perspective is. It's going through automation, algorithmic approach, right? All that requires the breadth of understanding in data science. So I definitely believe marketing is a huge area where data science and even now Gen AI techniques will be embedded and applied in future.
Thank you.
I think I'd like to quickly add some of the dividends you might get from this are not even, or rather the biggest dividend, to your surprise, might not even be technical, but rather your ability to work with people more effectively. Like one example I could give is a very big global financial company. I remember they were doing an interview for a director role, which is just a management role. So you're not really meant to be data scientists as such. But the last person hiring in the final interview placed a lot of weight on the ability to just code ad hoc so that your junior people have trust in you and they know that you got their back and you can help them out at some point. So I think that might be another angle here. So at least you're able to speak their language when you're setting up all these marketing experiments, and you're able to help them out if somebody's stuck.
Thank you, everyone, for all of that. Next question. When recruiting for your team, so I guess, Robert Devaka in particular, what are the most common reasons that candidates are unsuccessful?
One is lack of experience. It depends what level you're hiring at. I mean, a CV is only a light indicator of anything. So, it's lack of experience, lack of confidence. I don't mind if they don't know anything, but if you can see that they are willing to go out there and learn. It's like most of the things you do there, it's like, well, you're not going to know, but are you the sort of person who will ask questions and learn and pick up new skills? So I suppose that's a sort of a confidence thing, So yeah, experience and confidence to go, okay, nothing's perfect, but in a situation, you will go out and ask how to do it rather than just sit there and spend time. So I think that's very, very necessary, that these are self-starters and are willing to learn.
Yeah, so I can add a few bits because we've done quite a few recruitment. So I think it's varies as well from the actual data science position, whether it's an entry level or experience level, right? Experience is like probably just early 2 to 3 years experience level, right? It varies quite a lot. So at early stages or early entry level data science, we usually, we don't worry too much about technical aspect because we know they are joining from university or some other area. So I think it's more about critical thinking and problem solving. We mentioned that quite a few times before, right? Because we have to have some selection criteria. It gets very then sophisticated when it's a slightly experienced area of data science. So there are 3 skills that we look for, the team looks for, right? And now we know, right? Every data science job advert is there. There are like, dozens or if not hundreds of applications. So we have to have a way to select them. So I think first one is technical. Technical, we start with maybe it could be a very quick Python test, right? Some organizations do, some don't. The second, and that's where, 60-70% of candidates may be unsuccessful. The second one is breadth of knowledge, right? Understanding, we talked about maths and stats, very fundamentals of data science, right? Not like a depth of knowledge in computer vision and NLP to scare off the candidate. So very, very basic fundamentals, right? That's where some of the candidates can be unsuccessful. And the last bit, if the candidate is successful in Python, say technical skills and fundamentals, the last bit, if you're left with like 2 or 3 candidates and we have to choose one, the final bit we go for is, critical thinking and problem solving skills. Or sometimes, very rarely I've seen like specific domain knowledge, subject matter expertise a candidate has. But I think it's mostly about critical thinking and problem solving because every problem is so different. So I think these three skills from interview perspective are very, very important.
Thank you so much. Conscious we've got 4 minutes left to go, and due to my sort of shoddy hosting, there are a number of questions left. So I'm going to just answer a couple of the easier ones. Will there be a second intake in March 2025, or will the October one be the only one this year? I would say it's likely at the moment. It's just the October one that is confirmed. We will be running them next year as well. It's just we don't have confirmed dates for those yet. Will there be experts joining from domains other than finance? What I'd say, yes, is the answer. The model we have is that we have a different industry mentor for each of the courses in the program. So while I can't guarantee what industries they'll be working in, many of these are people that would have worked in a number of industries. And I think there will be time for one more question, which I will go just very quickly for this one, which is, as well as Python and R, what other important technical skills should be on a data scientist priority list? And maybe if whoever answers this could try to do it in 1 minute, that would be wonderful. Just to set you a challenge.
2 bullets. I would say stick with the basics. Learn to do XGBoost off the top of your head and learn to do one clustering algorithm, let's say k-means, standing on your head. And once you do the basics, then your intuition will tell you what to do next. That would be recipe for me.
That's wonderful. Thank you. And I'll just answer this one quickly. When writing on CVs, should we call this a career accelerator? Will employers understand? Do you know if the course is valued abroad? I think fundamentally the answer is it will depend on the employer, and it's probably down to sort of how you write about the program. The fact is this is a University of Cambridge program. It's non-credit bearing, but it is taught to level 7. So it's a master's level program. And I think that, I would say speak to your enrollment advisor further about the details on this, but yeah, it's as I say, it's a University of Cambridge program, and that's how you can put it on your CV. Right, we are out of time, so I just wanted to thank all the panelists first of all for the time. I mean, you've given up some very valuable time for this, but also for everyone attending. I hope you've got a lot out of the session. As I say, we really do appreciate you joining. Please, if you haven't done so already, if you're interested in the program and want to find out more, enter your details into the page and speak to an enrollment advisor, and they will be able to guide you through the rest of the process. I think that's probably the main thing to say. Yeah, the next intake does start on the 7th of October, and you want to be applying by the end of the month to be in with the best chance of getting into that, because the spaces are starting to fill up. So that's everything. Thank you again for your time. I hope to see many of you on the program. Bye.
Thank you very much. Bye-bye.
Thank you. Bye-bye.